Imagine waking up one morning and the world is just fundamentally different, but not in a way you can actually see right away. Welcome to a terrifying explainer, where we're going to take a totally mind-bending physics thought experiment and treat it like a real-time sci-fi survival story. We are looking at what would happen if the Earth started expanding completely uniformly from the crust all the way down to the core, right beneath our feet.
So let's dive right into this. What if the Earth beneath you started growing exactly 1 centimeter every single second? I mean, in that very first moment, you'd probably just feel a tiny weird jolt. But after that, nothing. You wouldn't feel any ongoing acceleration. You'd just be moving steadily upward. But make no mistake, behind the scenes, an absolutely unstoppable clock on your apocalypse timeline has just started ticking.
Let's start with day one, the first jolt. Okay, so at first, this whole expansion thing seems completely harmless. You go to work, you grab your coffee, look out the window, everything looks perfectly normal. But the unyielding mathematics of the universe, they are silently reshaping the planet. By the time you go to bed that very first day, the ground beneath your feet has seamlessly pushed you almost a full kilometer higher into the sky. Exactly 864 meters to be perfectly precise. You didn't even feel the climb, but the Earth's radius just got significantly bigger in a mere 24 hours. Now, this initial growth builds a really sneaky, false sense of security. You'd probably think, hey, if the Earth is expanding that fast, I'm going to be crushed by gravity, right? Well, not yet. Gravity hasn't quite caught up to the stretch. You see, surface gravity is proportional to the radius. Yes, the planet is getting way more massive, but you are also getting physically further away from the center of it. Because of this little quirk in physics, if you weighed 70 kilograms yesterday, you'd only weigh 70.01 kilograms today. You literally wouldn't notice a thing. To put this in perspective, think about that classic math puzzle. If you tied a rope super tightly all the way around the Earth, and then you wanted to raise that entire rope by just 1 meter, how much extra rope would you actually need? A few miles? Hundreds of miles? The answer is actually only about 6 meters. Circumference scales really predictably with radius. So even though the Earth's total circumference increases by a whopping 5.4 kilometers on day one, mathematically, that is only a 0.01% stretch. Everyday concrete expands and contracts more than that just from the sun coming up. So our buildings and roads survive this initial stretch without a scratch. But here's the catch. The first true signs of doom are entirely invisible to us on the ground. Within just a few hours, the incredibly precise timing of our global GPS satellites is completely ruined. The satellites themselves are still floating around in roughly the same orbits, but their tight synchronization with the ground stations, totally broken. Oh, and if you happen to have a highly accurate old-school pendulum clock sitting in your living room, by the end of day one, it's already running 3 seconds fast. Which brings us to 1 year, crumbling infrastructure. Fast forward 12 months, and all those invisible, mundane inconveniences, they've rapidly snowballed into a widespread catastrophe. Now, gravity's about 5% stronger, but honestly, that isn't what destroys our power grid. What destroys us is that the ground itself has literally stretched 5% wider. This relentless expansion just tears our interconnected world apart. Huge concrete structures crack, elevated highways collapse, power lines snap like twigs, and those vital undersea internet cables sever completely. We are now isolated in the dark, watching the modern world fall to pieces. And remember that pendulum clock? Yeah, it's now running a full 5 days ahead. Moving on to 40 years, the gravity trap. As the decades slowly tick by, the true enemy of human survival shifts. It's no longer the physical stretching of the ground. It's the inescapable, crushing weight of gravity. By year 5, surface gravity is a full 25% stronger. So if you were 70 kilograms on day 1, you're now dragging around 88 kilograms everywhere you go. By year 10, gravity's up 50%. And by the time we hit year 40, Earth's gravity has straight up tripled. At this stage, simply trying to take a single step forward requires absolutely superhuman effort from even our strongest Olympic athletes. But you know what's really fascinating? In this stark, kind of ironic contrast, our artificial creations actually outlive the natural world. Surprisingly, most major skyscrapers survive this intense gravity just fine. Their limiting factor in design was never really their own weight. Architects over-engineered them to withstand incredible shear forces, like hurricane-level winds. But nature, trees, crops, forests, they were definitely not designed for this. Under 3 times normal gravity, they are completely crushed, collapsing entirely under their own immense weight. Now we reach a century toxic Earths. Let's just say you somehow managed to survive to the century mark, scavenging around in this flattened, unrecognizable landscape. Well, the planet has now become completely hostile to human biology. Experiencing 6 times normal Earth's gravity, or 6 Gs, is an absolute death sentence for human mobility. It literally means your heart can no longer fight the downward pull to pump blood up to your brain. You would pass out just trying to stand up. At this nightmare stage, only tiny insects or sea creatures that are suspended in water are physically capable of moving around.
And, as if the crushing weight wasn't bad enough, the atmosphere itself turns against us. Assuming the atmosphere expands alongside the planet, the surface air pressure has risen massively. You've got this extreme gravity pulling the air down, plus just a sheer massive volume of new air. It thickens so dramatically that taking a breath of ordinary everyday air is now highly toxic due to lethal oxygen levels. So humanity's last desperate gasp might look a little something like this. A few remaining survivors lying completely flat, permanently confined to horizontal pressure chambers just to keep their blood flowing, entirely tended to by automated robots. It's incredibly bleak, but this depressing reality is where our personal human journey ends. We simply cannot survive physics past this point. Which brings us to the grand scale, the cosmic finale.
While humanity quietly fades away into the dark, the story of our expanding Earth shifts its focus up to the stars. Around 3 centuries into this relentless expansion, our newly swollen planet's immense gravity reaches out and grabs hold of our most ancient companion, the Moon. It slowly spirals inward, eventually crossing a fatal astronomical boundary known as the Roche limit. This is the exact mathematical point where Earth's tidal forces become vastly stronger than the gravity holding the Moon together. What happens next is a tragically beautiful sequence. You see, the Earth doesn't just awkwardly crash into the Moon. First, the Moon spirals in, closer and closer. And the second it hits that Roche limit, the tidal forces completely overpower it, and the Moon literally shatters into billions of pieces of debris. For a brief, incredibly majestic period of time, our barren, highly toxic Earth actually gains a spectacular set of planetary rings, just like Saturn.
The timeline from here on out is just absolute cosmic chaos. Now, full disclosure, under realistic physics, adding this much mass to a planet would eventually exceed the fundamental strength of chemical bonds. The Earth would actually contract under all that internal stress, collapsing down into something resembling a sputtering white dwarf star. But to follow our sci-fi explainer premise to the very end, we're forcing an even darker, rigid conclusion where the planet's density stays exactly the same as the radius keeps expanding.
If the Earth's mass keeps steadily increasing according to our original impossible premise, right around year 1500, it passes a critical universal threshold known as the Chandrasekhar limit. This is the absolute maximum mass allowed for a stable white dwarf star. By pushing past this stellar limit, the planet ultimately collapses under its own impossible density, swallows itself whole, and becomes a black hole. So, we know exactly how the solar system falls apart in this explainer, starting from a tiny, imperceptible centimeter of growth all the way to a literal planet-eating black hole. But looking all the way back at day 1, it really leaves you wondering, if the end of the world wasn't some sudden fiery explosion, but just a slow, calculable march of unstoppable physics, what would you do with your last few days of normal gravity?